Hi. Welcome back to my channel. In this video, I will demonstrate how to communicate via Modbus TCP from a smartphone to a Modbus TCP server using MIT App Inventor. This allows me to read the values of holding registers in the Modbus server. Let's get started. To communicate via Modbus TCP, we need an additional extension in MIT App Inventor. This is the Modbus extension used in the App Inventor. Please download the zip file, which we will then import the extension from. These are the files inside the download folder. com.modbus.aix is the extension file that we will import into App Inventor. There are several example blocks that we can open in App Inventor as a reference. There's an APK file that we can install to see the usage of Modbus TCP on a smartphone. Lastly, there's a PDF file containing instructions on how to use this extension. Here is the designer view in MIT App Inventor. In the component palette, don't forget to import the Modbus extension. The components used are as follows: text box for inputting the IP address of the server, label indicating the connection status to the Modbus server, connect button to initiate a connection to the Modbus server, disconnect button to terminate the connection, and label to display the values and the registers on the Modbus server. Additionally, there are hidden components: clock for reading Modbus values every 2 seconds, Modbus extension for Modbus communication, and clock for timeout while reading Modbus values. Here's the block code used, starting with initializing the global variable response. Then, in the screen initialization event, disabling all clock timers and initializing Modbus. In the disconnect button click event, close the Modbus connection, set the status label to disconnected, and disable all clock timers. In the connect button click event, initialize the Wi-Fi connection to the TCP IP address written in the text box with port 502. Set the Modbus protocol to 1, TCP, and execute the Modbus open command. If the connection is successful, activate the timer to read Modbus values every 2 seconds. In the clock read timer event, every 2 seconds, read the values in the holding register. In this example, it reads with address 0 and slave ID 1. Then, activate the timeout timer to start reading register values. In the clock's timeout timer event, if the global variable response is not -2, it will display the value of the response variable in the label. The value -2 indicates an error occurred during the Modbus value reading. I'm sharing the MIT App Inventor code. Please download it from the link provided in the video description. Let's test the application using the MIT App Inventor companion on Android. I'm using a Modbus slave simulator as a simulation of a Modbus TCP server. In the Modbus slave application, click on connection and then click connect. Select the Modbus TCP IP connection, and click OK. The Modbus TCP server is ready. Next, on your Android device, ensure that the IP address matches the computer's IP address. Then, click the connect button. If successful, the status label will change to connected, and every 2 seconds, it will read the value of register 0 on the Modbus server. When I change the value in register 0 on the Modbus slave, the value on Android will also change according to the value in register 0. To conclude the video, we've learned how to communicate via Modbus TCP from a smartphone to a Modbus TCP server using MIT App Inventor. By importing the Modbus extension, we can easily manage connections, read, and display register values from the Modbus server. Through the app we've created, we can connect to the server, read register values periodically, and respond to changes in register values on the server in real time. Thus, we've successfully built a simple yet useful application for monitoring and controlling devices connected via the Modbus TCP protocol. Thank you for watching this video, and feel free to ask if you have any further questions. See you in the next video.